and because of higher density, penetration of the particle through the filter media will be higher. So as I am showing you this media is used for air filtration application for pre-filter. Okay, for example, HVAC filter for this room, we need the clean air. So for the clean air, we can have the HEPA filter. Okay, HEPA filter one, but because before the HEPA filter, we can have pre-filter. Okay, before the HEPA filter, we can have a pre-filter. So role of pre-filter is to arrest the larger particulate matter, but it will allow the finer particulate matter through it. Okay, because it cannot arrest the smaller particulate matter because it is quite open in construction. Okay, so it is termed as pre-filter. Here another media I am showing, this is for a liquid filter media. If you see, this is the oven fabric. Okay, the front side is different, back side is different. That also I will discuss in due course of time. So here this is the cake side. Okay, this is the back side. Why I am referring to the cake side? Because the disposing of cake must be good. Okay, that is one of the property which is required. I mean, in subsequent lecture we will see how is it important to dispose of the cake. Now tell me whether the cake should be disposed of to the landfill area or what to do with the cake. Whether the cake is really important for us or it should be always disposed of. Yes, depend upon the requirement, because if you are going for mineral application, if you get the mineral should not be disposed. So for mineral application, that is the useful matter that you can make use of. Okay, so but suppose if you are going for wastewater treatment, so whenever you are getting the cake, that can be disposed of, because in Amritsar and several places you can find that zero water discharge. What is that terminology? Zero liquid discharge. So basic idea here is that the same water is recirculated in the process. Sometime it may come through reverse osmosis, sometime it is maybe from the ultrafiltration, but again we are using this. But suppose if you are going for white goods, it is always advisable to go for RO, reverse osmosis, whenever you are making use of that water. So you will get the dry cake. Liquid, see, liquid can be reused in the process. What? Media. Yes, yes. Media, it is not that it is for one time use. Okay, so it can be used repeatedly because it is a continuous process. Okay, again, if you are going for the RO filtration, it is a continuous process, it will happen. But time to time, you will have to go for backwash. Okay, so that is necessary for membrane filtration. In all membrane filtration, time to time. Yes, yes, regeneration is required. Okay, because membrane is very costly, so you cannot throw it out. So time to time you will have to go for regeneration. Okay, okay. If you see further to that, if you talk about the surface filtration, depth filtration. Whenever I talk about this kind of filter, it will be at certain depth the particle will be arrested. So this is known as depth filtration. Surface filtration means it should be on the surface. Why you are not going to the depth? Because the depth filtration will lead to the higher pressure differential. Okay. Yes. Okay, because this side is more smooth. Okay, because of the smoothness, it can dispose of the cake, because that is why it is engineered. This material is engineered in a particular way. That also I have shown you that this side will be rough. Okay, but this side is very smooth. Okay, because this can be done by means of weaving. I will tell you in due course of time. I will tell you this side has to be smooth so that you can dispose of the cake properly. Suppose if you are going for span yarn, I don't know how many of you know the span yarn, hairy yarn. So span yarn will be on the back side. Because of its hairiness, its filtration capability will be more. More and more you can have the filament on the front side. Front side, because of the filament, it can dispose of the cake in much better way. If you see the structure of denim, because one of the candidate wearing denim, see back side is different, front side is different. Okay, how is it possible? So it is possible by means of weave structure. Okay, so that way we make the weave structure such that This side is smooth, so can then dispose of the cake properly, and back side is rough. Okay, that will give you the more filtration capability. Now, one of the interesting challenge, there are many challenges. So, dispose of cake is one sort of challenge, but there are many challenges. Suppose if you make this structure very compact, okay, then what will happen? Pressure drop means the pressure drop directly linked with the energy requirement. For the industrial perspective, energy requirement plays a vital role. Unnecessarily, if you are using a filter media which is very compact, then obviously energy requirement will be more. Okay, but the filtration capability will be high. So we need to have the balance between the filtration efficiency and also the energy requirement, energy balance. So pressure differential in filtration, remember that three aspect is more vital. Wherever you go, it may be air filtration, it may be face mask or whatever. Okay, wherever you go, three aspects are very, very important. One is the efficiency, second is the pressure drop, and another one is the life of the filter. These three things. Life of the filter. Efficiency, definitely, efficiency. Because sometimes it can so happen that smaller particle efficiency will be lower. So that's why there also we talk about the fractional efficiency. Larger particle efficiency will be more. So efficiency is not that it will be equally applicable to all sort of particle size. So therefore in the research study, one must go for fractional efficiency to see what is the efficiency at different level of particle size. Because if you are giving a broad picture, gross picture, that may not tell you that its performance is good, because that all depends on the particle size, because larger particle size efficiency will be good. Another restriction is about the sensor. Certain sensor cost will be shooting up if you are going for very high sensitive sensor. For example, if you are going for SMPS, okay, scanning mobility, another is the dynamic light scattering, which is used for liquid filtration. Okay, so it is starting point is important. Starting point, what is the micron value of the starting point, that is important. If you want to register or if you want to measure the particle size at a very small sizes, the cost of the equipment go into in a 80 lakhs, 1 crore. Okay, normally the sensor might cost you 20 lakhs. Okay, but it can go up to more than 1 crore if you want to find out the particles which are below certain value. Okay, so sensor cost is very, very important whenever. So it is not that it is giving you at a particular size of the particle, if you are getting efficiency, it is all fine. Not like that. It all depends on the application. Suppose the application demand that very fine particulate to be removed, so we must see what is the efficiency at that particular level, and for that the sensor requirement will be different. So different application, that's why I need different kind of setup. It is not that in a single setup we can do everything. It is not possible, because everything should be aligned. Okay, sensor should be aligned, everything should be aligned. Now if you see here, I am showing you surface filter and another one is depth filter. In depth filter, the retention, if you see, it could be 60 to 90%, okay, for a particular size. Okay, in surface filtration, you can have the retention like this. So a particular size, if you say the retention is 90% for this particular particles, I think there is some problem. Is it okay? So we can get 99% efficiency for that particular size. Okay, so that is possible because it is an absolute filter. Okay, because the pore size is very uniform, but whereas the pore size is not very uniform, okay, and because you can have the small pores as well as large pores, so you cannot maintain the one particular efficiency level for a particular size. That is not possible. But if you are going for a woven fabric, you can maintain a particular efficiency level, okay, high efficiency level, okay, particular efficiency level, and that could be constant. You can maintain it at a constant level. Now, if you see, the concept of complete blocking filtration and bridging filtration is important, because if you talk about the air filtration and cake filtration, mostly if you will find this thing is very prominent. I am not talking about the ultra filtration, RO and all this, because this matter. The pore size in the membrane matters, because in the liquid you are having few particles. Okay, particles load will be much lower if you are talking about the reverse osmosis, ultra filtration. Okay, as the particle load is very less, so therefore the blocking mechanism basically work. But whenever the particle load is more, in that case quick cake formation will happen and the cake will take part in filtration process. It is not after the cake is being formed, the cake act as a filter, not the fabric. Fabric roll becomes secondary. So it basically initiates the cake formation. Once the cake formation is over, then it takes part in filtration. If the point is clear. Okay, so but it also happen in the case of industrial filtration. Okay, in many cases, people basically if they don't attend a proper class or they don't read through the literature, they will always think pore size is larger, so particle will pass through. It's not like that. This is not the philosophy. Basic philosophy, it can that we can have the breach filtration. Okay, and breach filtration, it is possible to capture even the small particle. Yes, when the cake, because cake will form in a very quick span of time. Okay, sometime what happened, the people going for pre-coating. Pre-coating means you go for cake formation, okay, by using some, that I will also tell you how to, what material to be used. So cellulosic component can be used for pre-coating. Once you are going for pre-coating in some of the application, so better cake formation will be there, disposing of cake will be better. So pre-coating is also essential in certain application. Now if you see the depth straining mechanism, depth retaining mechanism, at certain depth it is retained, okay, but in certain depth it is straining, because we are thinking, we are conceiving the pores like this, but actually the pores in the non-wovens is interconnected in nature. But researcher, what they used to do, they conceive the pores like this way, zigzag manner and all this. But actually non-woven pores are not zigzag manner, but the point here is that they are all interconnected pores. Particle can may be passing through from the top surface, but it can get caught at certain level. So depth straining is very common, but the depth retaining in the case of liquid filtration is uncommon. In air filtration it is common, depth retention. It is very common in the case of, like if you are using the pre-filter, depth retention is common in the case of air filtration. That is why air or liquid, in whichever is the case, flow velocity basically very important. If you are having dominant flow velocity, then obviously the retention at certain depth may not be possible. That is why the flow regulation is very important. Okay, it is not that suppose if you are going for any designing of the filter media or filter HVAC filter or whatever, why you are going for first of all pleating? What is the reason for pleating? So we can get larger surface area that can be accommodated in a smaller space. Even in the automotive also, we go for pleating so that we cannot accommodate larger surface area. Pleating. What is the basic purpose of pleating? Basic purpose of pleating is the reduction of the velocity. If you can reduce the velocity, that always helps in capturing of the particles. That is the basic philosophy. That is why the people going for pleating. Okay, again in the oil filter and everywhere, space is one aspect, but it is better to say that by giving you the more space, the volume flow divided by the area, that is filtration velocity. Volume flow will be meter cube per minute divided by area meter square. So if you do that, so from that you will get the velocity. So velocity should be as small as possible, whichever is the application. Okay. But if you are having the nearly zero velocity, that will be perfect. But the problem is that there will be huge requirement of the filter bags, or in this case a larger surface area is required. That's why it also is a balance. You have to make a balance. What should be the sizes that you can accommodate? Because if you can reduce down the velocity to the zero level, obviously you can have more and more capture. But we cannot go for zero level, as because the size of the filter will be huge and that will be difficult to manage. Now this is the tortuosity factor. So that can, again it is conceptual, that machine whosoever measure the fabric properties, they can provide you the tortuosity factor, and this is how the tortuosity is defined: length of the pore path divided by the thickness of the material. Greater the tortuosity, greater will be the capture of the particles. If you see, sometimes it is also being said that if you are making the non-woven needle punch, if you are going for angular needling, so in the case of angular needling, the path of the pores will not be straight. Okay, if the path of the pores is not straight, that will be better for filtration application. So different types of structure is there, and non-woven, one of the problem here is that you can, if you are having straight path after punching process, you must have certain, to certain extent I will discuss the non-woven fabric also, manufacturing also. Okay, so if you are having straight path, so in that case the particle can penetrate through. So if you see another aspect, important aspect is the cake filtration. Okay. Okay, so point here is that in majorly air filtration application, non-woven is preferred. Non-woven is preferred, like this material is preferred. Okay, in majorly air filtration application. Okay, majorly. Whereas in the case of liquid filtration application, people prefer woven fabrics. But again, there is a but. People are moving towards development of non-woven, because last class also I have shown you that very compact kind of non-woven can be used, which can assist for surface filtration. So that non-woven can be specially made. What is the advantage of non-woven over woven fabric? Anyone? No. Cost, obviously non-woven cost will be lower. But what is the advantage? Basic advantage of non-woven?
Smaller particle catching as compared to their pore size. The pore size distribution.
Okay, any other point? Right, this is.
Sir, there is no uniform pore size.
No, that is what, but uniform pore size is not a very good point. As he said, that point is correct, because each and every fiber take part in filtration. Each and every fiber here. But here the filaments are consolidated. Okay, then after you make the yarn, then you make the fabrics. Okay, so here individual fiber take part in filtration. So obviously filtration capability will be more, but there is one major point you are missing. What is that? Yes? Width, you can consolidate it. I mean, you can make it compact. One of the, as I told you, that there are three aspects: life, okay, pressure and filtration. Pressure differential, because in non-woven you can make more voids as compared to, for similar retention, non-woven can give you more voids. More voids means what? More voids means less pressure. Okay, but one of the problem with non-woven is that life, as compared to woven fabric, the life will be less. So you will have to make again balance between the life and the pressure drop, because here the depth filtration will be there. If the depth filtration is there, okay, you intend to go for surface filtration, but you are going for depth filtration. So what will happen? Life will be reduced. Okay, so because of less pressure drop across the filter media, you will get better energy saving. Energy saving will be better. Okay, for the same capability of efficiency, that is the advantage. But one of the negative aspect of non-woven is the life will be relatively less. Is the yes, pressure drop, that is the plus point. Otherwise, the woven fabrics should have been totally replaced by non-woven. Another point is there in the case of non-woven, the dimensional stability in the case of woven fabric will be better as compared to non-woven, because if you see the process, the material will be under constant stress. Stress level to the material, unlike the air filtration process, liquid filtration application stress level will be very high. Okay, under the stress level, it will not deform, but if you apply certain stress level, here the material will be deformed. Okay, if it is not compactly packed. So that is again another problem. Okay, as the life is concerned. So as I am saying, the three aspects can define which material can be used, should be used. One is the filtration efficiency. Okay, fractional filtration efficiency, better to say. Second is the pressure, and third is the life. In three are very, very important whenever you are selecting the filter. Now in the cake filtration, if you see, as I told you that once the cake is formed, the roll of cake becoming very, very important, because the fabric roll becoming secondary. But most of the cases we forget, we assume that particles as spherical body. Okay, that is our assumption. That is again a problem. Okay, basic problem in most of the research is that we take the data and never think that what kind of data we are getting. That is the problem. We can have different kinds of the dirt particle. Okay, it can be flake like, Okay, but its equivalent spherical size will be much lower. It could be needle-like, equivalent spherical size will be much lower. Okay, so if you talk about the needle-like particle, capturing will be more in the case of needle-like particles. And whether there is a hydrophobic or hydrophilic particles are there, that also influence the cake formation, the nature of cake formation. So it is not that you can see the data from the instrument, that is okay, but you will have to see that what kind of particulate matter is. It is a differently shaped or it is a nearly spherical, but particles are never in spherical shape. So again question arises that why we take the spherical in shape? What is the reason? Why not other structure or other type of dimensions? Why we take it as spherical shape? Any answer? Why we take the particles at equivalent spherical body? What is the basic reason? Why sphere? Why not in other shapes?
Whichever direction it moves, it will have the same calculation wise it is easy to calculate.
Because sphere is only material where you can indicate the dimension by diameter. But if you take any other shape, you can have multiple dimension to indicate the size and the shape of the material. So sphere is the unique in that sense, because by diameter, indicating the diameter, we can indicate the size of the material. That is why we use sphere as equivalent body. Okay. Now if you see in the cake filtration, little bit I have written about the cake filtration. Cake compressibility is very important. Okay, the ability to cake to compress under pressure affect the filtration rate and cake properties, because cake property will be changing under cake compression. Okay, so is it a compressible cake or not? That also matters a lot.
But the cake formation is we will not be able to control, right?
So it all depends on the type of the solid particle you want to arrest, because solid particle sometimes could be compressible, it could be non-compressible. Okay, so depending on the type of solid particle, compressibility will be there. Filter rate, this is again a very important concept.
With the time that the cake becomes thicker and thicker and it
Yes, that's why you need to dispose of. Like yesterday I had shown you, in a dump filter it is gathering, then the cake is disposed of on the other side, because suction is effective in a particular zone and some zone it is not effective. That's why the disposing of is possible.
But if we have a tubular kind of a filter, then disposable.
No, that's why in a tubular kind of filter means, if you talk about the ultrafiltration, their contaminant level is very, very low. Okay, we cannot go for immediately that application. See, if you go to okay, we are just talking about the what you can say, the wastewater treatment. Wastewater treatment, our several places, after several stages, after you remove the large particulate matter, debris and everything, then finally we go for that particular application. You cannot use that application immediately. Are you getting my point? You cannot use the ultrafiltration immediately having the large quantity of the solid. You cannot, because that is also referred in one in the PPT also. What should be the recommended value of the solid content, so that you can go for ultrafiltration, RO. If you are having higher solid content, there is no point of going for RO immediately, because it will damage. That's why whenever we talk about the depth filtration, okay, or blocking filtration, we'll have to see the context. Okay, for example, in automotive clean air, although I am referring to air filtration time to time, for clean air, after its life is over, we throw it away. Okay, but it will take at least 6 months to saturate. But in Indian road condition, it may be 2-3 months, but it will take at least 6 months to saturate. Why I should have cleaning? Here, cleaning mechanism is not required. Only the exception is the water tank. If you see, the water tank moves over the dusty land, lot of dust is emitted. So the people going for cleaning also, intermittently cleaning, because they don't have to change the filter. Intermittent cleaning is there. So in certain cases we go for intermittent cleaning also, but normally in all automotive it is under depth filtration. So depth filtration is workable only when the dust concentration, particle concentration is very less. Okay, we can have reasonable time period after which you can throw it away. That is as simple as possible. But surface filtration, we will have to go for cyclic process to regenerate it, like we are saying regeneration. So cake filtration is widely used in various industries. wastewater treatment, food processing, chemical processing, mining. Okay, now you can see this is the kind of pre-coat material. Okay, D, very light cellulosic matter, just now I mentioned. Another material that can be used as a filter aid, especially in the situation where silica cannot be tolerated. So here if you see, this is the layer, this is the dust cake. Okay, I will show you the application. So this is the pre-coat layer, inside it you are having the main material. So initially you must pass the pre-coat layer, okay, you must pass the liquid having the cellulosic matter, for example, to make a pre-coat on the fabric surface, okay, to pre-coat on the fabric surface, so that you can arrest more finer particulate matter. Okay, I will show you what is the advantage. So to protect it from blinding, so pre-coating can give you the advantage of blinding, okay, to protect it from blinding, so life will be more, to assist in the collection of particularly fine particles, to enable more efficient cake release. So these three things is possible. Coating means that in the liquid bath you can have cellulosic matter, for example. You can initially you can expose it with this liquid. Okay, once it is getting exposed, so obviously fabric layer we can have some pre-coat. Then we can run the main material through it. Okay, main I mean liquid and solid through the assembly. Okay, so it will act as a pre-coat. If you see here, if you see outside it is a pre-coat, inside it is a cake. Okay, so it can give you the great advantage in certain application. Okay, suppose in silica is not required, cannot be tolerated, so obviously you need the efficiency at much higher level, so you can go for pre-coat.
This pre-coat has to be porous in nature.
Yes, yes, obviously it has to be passed through pre-coat and also, but pre-coat can give you more filtration capability, okay, and it can be also disposed of in a much better way. Okay, because normal cake filtration may not be disposed of, okay, but pre-coat can be disposed of in a much better way. Now another classification is dead end filtration and cross flow filtration. Now in a dead end filtration, as I told you, that it is the flow will be perpendicular to the plane of the fabric. Okay, cross plane, like ultrafiltration, RO, everywhere you will find it will flow in the plane of the fabric. So ceramic, metal, polymeric membrane, all type of membrane is possible. It can be made out of ceramic, it could be made out of metal and polymeric membrane. Manufacturing of membrane is also very great task. How to improve the membrane? Suppose if you make the membrane thick, okay, then pressure differential will be more. Okay, how to make a membrane fine, okay, and longer life? That is again a challenge for various applications. It is not this application. Wherever you go, for example, for high altitude, if you want to use the membrane inner side of the fabric as a breathable layer, so there also it is important how to make the membrane very fine at the same point of time to make the membrane strong. Why it is required to be made very fine? So that the pressure differential can be addressed. It should be less. Okay, that is one of the tasks for the membrane manufacturer. I have seen in one of the international conference, the people are keeping the membrane and above it there is a water body. From the bottom they are flowing the air. So in the liquid you can see the bubble of air, because air is moving from here. This membrane is arresting the water body to fall off, but the bubble will be moving up, but water is not moving down, because the membrane size could be, size of the pores of the membrane could be 0.0001. Okay, it could be so small. Membrane size should be so small, it can allow the vapor, okay, but it may not allow the water. Okay, so membrane manufacturer, again that depends on the place to place, the membrane will be different. Now if you see here, flow direction, it will be parallel, so here proper cake formation will never take place, because it will be shearing all the time, it will be shearing out. But then how it is getting managed, so that also I will tell you. And dead end filtration is most common. Okay, dead end filtration, this is the dead end filtration, where it is perpendicular to the plane and here it is parallel to the plane. Now you can see the dead end filtration, blocking filtration. Okay, this is the testing, water testing and biotherapy manufacturing. So basically the contaminant low, as I said, it is very less. So we are going for blocking filtration in the case of dead end filtration. Contaminant contaminant level are very, very low. Now this is interesting to see. Okay, now the working principle of the tangential flow filtration. If you see, this is the cylindrical body we have talked about. Okay, and this is the particles which are moving through the cylindrical body inside. There could be also outside to inside filtration. Here I am showing you the inside to outside filtration. Okay, so this particles are moving through the cylindrical body. Okay, now it cannot, see, in this case the filtration is not possible because there should be restriction. If you see in the second picture, we are imposing certain restriction for the fluid flow. Otherwise, the filtration is not possible at all. As because you are putting a restriction, you are making the other side tight. What will happen? Because of this, you can have permeate flow. Permeate flow means the clean water will move through the membrane. This is the permeate flow. And retentate flow. Retentate flow means which is having some residual, which is having the solid particle. Okay, this again will be circulated in the process. So it is not a single setup. So there could be multiple setup. Once the retentant is passing through, it will move into the another unit. Okay, another unit, then gradually the water will get filtered out. Okay, and you are getting the solid content. Okay, in the retentant. Okay, so if you see, here is a particle, restriction is there, restriction must be imposed. Permeate flow, this is the permeate. So suppose here it is passing through the membrane from the top and from the bottom, although it is cylindrical. Okay, so from all over you will get the permeate flow. Okay, and this is the retentate flow. Retentate flow means which is having the particles in it. Obviously, the quantity of water will get reduced. Getting my point? Quantity of water will get reduced. Huh? RO, yes. RO ultrafiltration, okay, in all cases. RO, the setup is different. I will show you the setup for RO. Okay, the setup is different.
So in this case, when it goes to the second filter after this, the retentate flow, so there the concentration level of the particles will be higher. So there the porous membrane parameters are different, or it is the similar?
It is similar. It is similar. The same, if it is ultrafiltration, similar membrane are being used in all modules. Okay, but gradually it will be denser and denser. Okay, challenges will be more. Now if you see, there are two philosophy. One is that inside feed. Okay, here if you see the hollow fiber, here if you see, this is the hollow fiber. Okay, and this is the hollow fiber. In the hollow fiber you are having the semi-impermeable membrane. Okay, so basically it is flowing inside. Okay, and the picture I have shown you, it will work in the same philosophy. Okay, and in the other case, the feed will be from a outer side. Okay, feed will be from a outer side. Both are having their own advantage, disadvantage. Okay, inner feed, if there is a contaminant level is less, inside feed is better. If the contaminant level is more, outside feed is better. But outside feed, because you are getting the larger surface area, flow dynamics will be better, but the damage to the hollow fiber will be higher in the case of outside feed. Now you can see several membrane arrangement. So one is the hollow, tubular, this is the solid material, okay, plate and frame, okay, and spiral wound. So this spiral wound I will show you in the case of RO filter. This is specially designed for the RO filter. Okay, so it depends on the structure, how it is made. Now I will show you that how the ultrafiltration works in the situation of outside to inside filtration.
Components include lower and upper cap, clamp, housing, raw water distribution channel and separator, pipe, hollow fiber. The raw
water distribution channel and separators are situated in the middle of the filter. This specially designed inner distribution mechanism ensures that water is equally distributed in the module. For a modified PVDF, ensures a high chemical and mechanical resistance to the hollow fiber. The hollow fiber has smaller pores on its outer surface, creating the active filtration surface. This design gives the membrane a high capacity of contaminants retention. The hollow fiber is both highly permeable and easy to clean. Modified PVDF has a higher mechanical and chemical resistance compared to other materials. The nanoscale pores located on the outer surface of the hollow fibers allows the water to pass through the thickness and retain the viruses, bacteria, and solids larger than 30 nanometers. These substances cannot enter the fiber, they stay outside. The pore diameter of our hollow fiber is smaller than 0.03 microns. The filtration process takes place from the outside towards the inside of the hollow fiber, so the membrane can be used for highly contaminated water, has a larger surface area, and can be cleaned more easily. During the filtration stage, raw water enters into the module. Raw water stays out of the fibers. Filtered water flows along the lumen of the hollow fiber and goes to the module outlet. The polyurethane-based coating holds the fibers and provides the tightness to the module. The clean and raw water never mixes through the module. When the filter is blocked, contaminants accumulating on the outer surface of the fiber are removed from the filter.
This is the retentant.
During backwashing, the filtered clean water is
This is the backwashing.
As clean water comes out of the fibers, contaminants which have been accumulated on the fiber surface are pushed and removed. Concentrated sludge is discharged through the outlet. Backwashing is performed more quickly and effectively when combined with air scouring. When the removal of contaminants is not sufficient with backwashing and air scouring, chemically enhanced backwash and clean in place are applied. Our PVDF hollow fibers are extremely resistant to chemicals.
So if it is not possible by water, we can use the chemical or biological filtration. Backwash is also possible using enzyme. So there are ways to clean the filter media. This is another example for inside to outside filtration. So it is passing through the center of the hollow fiber, okay, and in centrally you are having the tube through which you are getting the permeate. Permeate means the clean water. You are getting the permeate. This is the hollow fiber through which the contaminant water is flowing, and then we can go. This is another backwashing technique. So for backwashing, the flow must be reversed. Using chemicals, okay. Yes, you can use water. If it is not possible through water, then chemical. Yeah, but depending on the chemical has to be selected. Again, after applying chemical, you will have to use the water also at the final stage. Now here if you see, it is best for inside to outside is best for low turbidity. Okay, for outside to inside is best for high turbidity. Okay, I am not showing all the, because these slides will be with you. You will get some idea. Risk of fiber breakage will be higher, lower in this case. That is the good point. So certain cases the inside to outside is better. In certain cases for high turbidity, the outside to inside filtration will be better. Okay, so if you see normal cases, mechanism based on the flow direction, thickness of the deposit increases, specific output to the filtrate material will decrease with time, because gradually the cake is building up, so filtrate will be less with time. But in the case of cross flow filtration, output to filtrate will remain the same after certain point of time. Thickness of deposit will remain the same after certain point of time, because it is not like the cake will build up just like this. So cake will never build up. So after a certain period of time, thickness will remain the same, specific output or filtrate will remain the same. Okay, this is. Now if you see the depth and membrane filtration, you can have complete blocking, because the blocking is the main concern in membrane. Complete blocking is possible, standard blocking is possible, cake filtration is there, intermediate blocking is there. So blocking obviously reduce the life of the media function, it can affect the function of the media. Now as I said that biological cleaning is possible for the cleaning strategies, backwashing. Physical cleaning is possible, people mostly go for physical cleaning, okay, and if it is not possible by physical cleaning, then they go for chemical cleaning. Okay, it is not that always going for chemical cleaning, and biologically cleaning is also coming up, okay, and you can use some enzyme for cleaning the membrane. So different membrane is having different pore size. If you see 10 to 0.1 micron, here ultra filtration 0.1 to 0.01 micron, nanofiltration 0.01 to 0.001, and RO it is further less. Okay. So at different stages we remove different kinds of material. For example, ions can be removed in the reverse osmosis. Small compound can be removed in the case of nanofiltration. Ultrafiltration can remove the virus and proteins. Microfiltration can remove E. coli, okay, and oil, micromolecules, colloids, suspended particles. Okay, so different filters is having different capability. Now going to the reverse osmosis, let us understand the mechanism of reverse osmosis also. And this is the cutoff of different liquid filtration technique. So depending on the cutoff, we will have to select that which kind of filter, membrane filter is applicable. Because this is the membrane filter, and the RO filter obviously need very high level of force. If you see the membrane filter, okay, Alta filter 0.5 to 10 bar. Here if you see 7 to 75, energy requirement will be higher, much higher. So unless and until you require the RO, you should not go for RO, because the energy consumption will be much higher. Okay, so that already I have discussed. You can have this slide, because you can see the advantage of microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Basically you are removing everything. Okay, even the monovalent ions, okay, multivalent ions, these are also being removed in the case of reverse osmosis. That's why it is suggested that reverse osmosis water is not also good for health, because we are removing everything. So this is the different types of membrane. You can have hydrophobic membrane, electrostatic interaction, adsorption. Different membrane manufacturers are also coming up in a different types of membrane. Okay, biologically inspired membrane are being developed. So different kinds of membrane are also being developed. So sometimes it could be electrostatic interaction, sometimes it can give you the adsorption, hydrophobicity. Okay, so earlier membrane we talk about the size exclusion only, but nowadays the new membranes are also coming up through research, so that can give you some additional performance. And this is the interesting for reverse osmosis. If you see, several layers are being used, and feed channel pressure, this is very important. Here you are having the membrane. Okay, membrane is not only one polymeric material, that is different polymeric material is there in membrane. Okay, 3 different polymeric material is there in the membrane. I will show you. And this is the feed channel pressure through which the permeate can pass through. So sorry, not the permeate, that contaminant water, concentrate. The concentrate will be able to pass through the feed channel pressure. I will show you that how it works. But this is the only the theory of reverse osmosis. Next slide I will show you how it works.
To all salts and inorganic molecules, as well as organic molecules. It is therefore a highly effective process for removing a variety of contaminants. Compared to traditional filtration technologies that rely on screen or filter to remove particles, reverse osmosis is a pressure-driven separation process that employs a semi-permeable membrane and the principles of cross-flow filtration. Filtech RO membranes are composed of a thin film composite membrane consisting of 3 layers: a polyester support layer.
You see, it is not a singular component. Polysulfone substrate and ultra thin membrane layer.
Coated by a proprietary fouling resistance layer.
This is the speed pressure through which the water can flow.
This thin film composite RO membrane is packed in a spiral wound configuration that follows the principles of cross-flow filtration, where the flow is applied tangentially across the membrane surface. As heat flows across the membrane surface, filtrate passes through.
So it is basically moving in a spiral direction, and it is moving to the center.
Filtech's membranes offer a special interlocking capability called IREC, which is an interlocking end cap technology offered to selected Filtech.
See, one module is attached to the another module. Okay. So up till this, the thing is okay. Got the idea? So in this case, basically the water moves, contaminated water moves in a spirally, okay, and gradually it moves inward, because it is made in such a fashion. So gradually the contaminated water will move inside, and inside you are having the tube, perforated tube, through which you will get the permeate. Okay, and contaminated water will pass through the spacer, because in between that membrane you are having the spacer. Spacer, if you see, you can get several video in the YouTube also how the spacer operate. Okay, but again you give certain restriction so that it can the water has to pass through the membrane, because that is the basic philosophy. You will have to put certain restriction, certain resistance, so that water has to pass through the membrane. That is the basic idea. That's why the pressure differential is so high in RO. Now coming to the centrifuge system, there are two kinds of centrifuge system. One is that perforated basket centrifuge, okay, and this is the commonly used. I will directly go to the pusher centrifuge because of time less. Only the 5 minutes I try to cover. Pusher centrifuge, I will show the video, because inside the pusher centrifuge there will be metallic body, perforated metallic body, over which you can have the textile fabric. Okay, and this can be used in the case of pharmaceuticals and suppose expensive minerals recovery. So there we can use the pusher centrifuge because it will be relatively much expensive. It is short, but maintenance cost will be also important. You can see how it operates. Cake is formed, but cake will be pushed time to time. Cake is formed and there is a pusher which is pushing the cake in a particular manner. You see, once it is coming to the edge, it is taken out. Cake will be taken out. So it will be pushed. Once the cake is formed, it is pushed. Again formed, it is pushed. So it is gradually pushing the cake so that at the end, whenever it is coming to the edge, it will be taken out. You can see at the edge it is taken out. So abrasion is very important because sometimes we neglect, we always think that efficiency is important. Abrasion also damages the fabric. So here you can have abrasion of the material with the particulate matter or with the solid matter. So abrasion is very important. Another is the pillar centrifuge. I will show you direct video, then the things will be clear. So it is basically slurry feeding. Initially it will be slurry feeding. So slurry is being fed. So see, slurry is fed, okay, and by means of centrifugal force you are you are extracting the water from the slurry. So here cake is washed. Filter cake washing. So dry spinning. Cake peeling and discharge. Although the same system is, I am showing one system to another, but whole system is embedded. Okay, so here it is basically you are peeling out. Cake peeling is there, and through the discharge mechanism you are removing the cake. So cake is peeled out. Through the discharge mechanism it is been taken out. The cake is taken out. So which one is batch process, which one is continuous process? Any idea? Out of these two, whether both are continuous process? Which one is continuous and which one is batch process? Or both are continuous? Both are continuous? All agree?
Stopping the process.
No, not stopping. Whether it is a batch or continuous, or it is only continuous, or it is only batch. Second one is batch. First one is continuous. Because you are for the washing and everything, you need another operation. During the operation, the filtration is not there. During washing and everything, filtration is not there. The first one is a continuous, because continuously you are pushing the material, okay. So it is not a batch process. First one is a continuous. Second one is a batch process. This one is a batch process. Okay, it is not that you will have to stop for batch process. It is a batch process. But then what is the advantage of this? The abrasion will be much lower. So it will act on the filter material, because filter material is also very costly. The life of the filter material will be better, because abrasion will be less in this case as compared to the previous case. So there must be some positive point. Remember that the batch process must have some positive point. Otherwise, why the people go for batch process? Always should go for continuous process. What the problem? Okay, batch process must have some advantage. So if you see, this is another setup for your blood filtration. Serum from blood is taken out. Okay, detection of biomarker. This is for cancer patient. Okay, we want to test the serum. Okay, there also tangential cross flow filtration is important, and this is a separate setup that has been shown that how it works. Okay, because see here it is uniqueness is that through centrifugal force, here you are having the filter media, you are pushing the solid particle one side, larger particulate matter in one side. So filter media can take out the serum from the blood. Okay, so direction of serum flow. So pores in oven and non-oven fabric. I think how much time I left? I think time is over, or okay. So this thing is important. So what I think that in my next tomorrow I am having lecture, first and the second, two lecture consecutive lecture I am having. So in two consecutive lecture I will discuss about the, this concept is important about the pore size and how to voids and all these things. Okay, because I should not uh, make it in hurry, because the understanding of these pores and the particle size is very important. Okay, so this part I will discuss in my tomorrow's class. Okay, along with the cake, because there are also several things about the media. Okay, okay, then we can go for a tea. The tea is ready. Okay, okay, thank you all. Any question? So till now I have discussed all mechanism where you can make use of media filter. Okay, then about the media filter I will discuss tomorrow's class.
Today I have some issues. Jet lag. Jet lag. See, in US right now it's night. Here is day. But once you travel from the US to India, have you noticed it? When you look at the globe, US where I live, and India where what the Jalandhar is located is really opposite side. Right opposite side of it. But one thing, when I look at it, it's really quite interesting. Why? The route that I come to Jalandhar, US to Europe, Paris, and then come back to Jalandhar. I don't know why they are not looking at the other side of it, which means US to Asian country, and then Jalandhar. It's the same. Well, distance-wise, it's the same. However, there is not that type of route. See, if there is the available, then probably I will take that one. Okay, today, this is really not a short kind of lecture, because evaluation and selection of liquid filtration system based on application. However, I have only small area of expertise, not all of the expertise. There is no way you can do it. So we're going to cover all of the area available in the liquid filtration area. First part of it. Second part, that is quite interesting, I believe, interesting to you. Have you heard of MBR, process for wastewater treatment? Have you heard of it? Membrane bioreactor. So we're going to go over something. So also there is the recent another technologies. So we're going to go over recent technologies that is applying in the wastewater treatment. So I don't think anyone currently covered the MBR or some of the newest technology. That's why I told you yesterday, you're lucky because you're going to learn newest technology available. Then how you want to select liquid filtration system? This is the filtration system. So the first, somehow you have to define application requirement, types of water or liquid, whether it's water or chemicals or food, beverage, pharmaceutical. The water, potable, wastewater, seawater. See, this afternoon we're gonna have some hands-on experiment a little bit. We can use some lube oil or some other things. However, we don't have enough time, so we're gonna use water. A simple water. Water with some sand into it. So probably later on, once we set it up, the experimental setup, then we make some groups, and probably in the afternoon sometime, you can do one group, use the constant the pressure experiment, variable pressure experiment, something like this. Then you could understand the equation that I gave you yesterday a lot better. But yesterday I just skim through it, but because if you don't do the experiment, it's hard to understand. Even though you understand, you forget really quickly too. So the purpose of filtration, what is the contaminant? What is the important solid material that we like to have it? And then product recovery, equipment and protection. Second one is the analyze the fluid characteristics. The viscosity is a really important one. The temperature, pH level is good. Professor Mukwate already covered the particle size. Distribution is important. And so loading itself is important one. And then third one, determine filtration requirement. Certainly this is efficiency related. And flow rate is important. The operating pressure, well, pressure and flow rate, that's critically important. They compare with air, the liquid, the pressure is really important parameter. Just like the previous lecture, is that the continuous or batch? Then how we can clean the system itself? That's the important part of it. And number 4, select the filter type. What type of? By configuration, bag filter, or cartridge, or self-cleaning, or membrane filter, micro or ultra cellular depth filter, and then mechanism, that's surface filtration, depth filtration. Now, fifth, material comparability. This is quite important. Comparability. The solution that you want to use, hey, here. When I work for the Cummins engine company, lube oil, we try to develop the lube oil filter media. Also the gasoline, fuel filter, the hydraulic filter. Then somehow you have to look at the comparability. Whether it's dissolved a little bit, then you have trouble. The cooling water is trouble. Cooling water is actually alcohol content is really high. So the alcohol dissolves some of the materials, organic materials. So it's comparability is quite important factor. And then what type of housing? The SS operation, not an economic factor. So economic factor comes normally first. Whether this one is expensive to make it or not. So, certainly the maintenance issue, change out, disposal. Now disposal is big issue. Luckily, US, we are still dumping away, land dumping away. But because land is huge, but in India, I doubt it. I doubt so. Disposal is a big issue. So later on, but he already mentioned about the PVDF, the membrane. That considered to be not really good material, but however, I doubt it. So they call it PFAR. Have you heard of PFAR? I'm going to talk about that one later. Yeah, TCO, this is big issue. Total cost of ownership. This is a big issue currently. Along with the greenhouse, that's actually related to TCO. We're going to talk about that one a little bit later at the sustainable filter media development. And then this one is important factor, the regulatory and safety consideration. Whether it's food grade, pharmaceutical grade, environmental regulation. Currently, there are so many regulations on water and everything. So, one is vendor and technical support. So, this is all necessary item to look at. Here, very leakage filtration by application. Back filter is the cost issue is really low. What about cartridge filter? It's moderate. Sand filter, quite low. This afternoon, tutorial 2, I'm going to start with sand filter, the example of sand filter. I think I don't know whether you have the copy of ebook. Do you have it? Not yet. So it starts with the sand filter, Fujimon. Have you? I don't know. Any person who actually visit Fuji Mountain in Japan? See, I traveled to India several times because I have the project with them. That's really close to the Fuji Mountain. The Fuji Mountain, around that area, there are a bunch of the so-called clean water. Actually, it's really clean water because the Fuji Mountain, top of one mountain, you can see the snow there and rain. Normally, they pass through the sand for 100 years, something like this. So around that area, there are several villages. They do use that water, really clean water, also tastes really good too. So basic technology, sand filter. But nowadays, there are actually some places, you have to pay to get it in. But the water taste is really great. If you like to visit the Japan, go to Fuji Mountain and taste their water. How delicious the water is. And then sand filter. Sand filter is the original filter material. But still using it though. And the membrane filter and centrifugal separator. However, membrane, the bad part of membrane is cost. Cost is quite high. There is one lecture about the membrane. I'm actually looking at the manufacturing side of it, how we can produce the membranes. There are several different type of membranes, so that we want to go over manufacturing, how they can manufacture something like that. Centrifugal and pressure lift. Vacuum belt. So application area, the industrial water and pharmaceutical, you can look at it, something like that. This chart is quite handy. So if you like to design something, so I don't want to go over every bit of it, but once you have this slide, also if you have a project or something, then you can look it up and get the right answer. This one is a little bit different from the other side of it. This one has the operational cost, scalability, flow rate, and filtration rating as well. Cartridge filter, bag filter, I'm going to skip. Sand filter, cartridge filter, bag filter, disc filter, membrane filter, and efficiency. Certainly, the sand filter 50 micrometer, and cartridge filter 1 to 10, bag filter 5, membrane 0.1 to 0.1 micrometer. And the cost issue and operating cost and the footprint, maintenance, and backwash requirement, replacement. Pre-filtration, and final one, I'm going to skip two. Selection liquid filtration system for chemical plant application. The efficiency is important one, solid handling and flow rate. See, chemical compatibility is quite important. The here footprint, the carbon footprint is quite kind of buzzword right now. Do you know what the carbon footprint is? Carbon footprint is. What is that?
Carbon dioxide that is being emitted.
Huh?
It's the amount of carbon dioxide that is being emitted in each activity, let's say.
Yeah.
And it's expressed in tonnage.
Yes, carbon footprint, that is currently the buzzword right now. The disposable is a big issue. So also well, I'm going to talk about something like this, the sustainable filter media development. But surprisingly, the carbon footprint, something like that, is quite big issue in Europe and Asia. However, in US, we are not actually paying much attention to the carbon footprint in US. But Europe is a big issue. Yeah. Also, the Asian region is the same thing. But since I'm living in US, we really don't care much.
Can I ask you why?
Huh?
Why you don't care about carbon footprint?
Every area, I'm going to talk a little bit about it. Every area, in US, certainly, I'm involved in the standard development. I'm quite active on the ISO TC 142. I'm the convener of two work groups currently. Also, I am involved in the ASHRAE. You know what the ASHRAE is? Yeah. American Society of HVAC and refrigeration. So it's huge. The members, we have the two conferences every year. Probably the member comes from the ASHRAE conference, about 5,000 people. So it's huge. So ASHRAE has a standard. The ISO has a standard. However, ASHRAE using different units. They are not using CGS unit, different unit. They don't want to change it. The other thing, ASHRAE has money to develop the certain things. If we like to have the standard, then this is trouble. We have to solve it. Then somehow we need research to solve it. So every time we try to establish the test standard, they create research project, and then someone has to write the RTAR, which is research proposal, and work statement, which is the go to the bid. So some university job one bidding, and then we have to choose one research institute so that they can get the project, and normally it takes 3 or 4 years. So once they finish the project and then get the result, we use that result for making standard. That's the 52.2 in every part of the standard came out of based on the research project. But what about ISO? ISO doesn't have money. Well, I don't know whether I can say it, but I'm quite involved in ISO. That's why I can tell you. ISO standard is following ASHRAE standard, modifying a little bit. And most of them are like that. That's why US is not much pay attention to some of the other world. Yeah? So,
another reason.
uh-huh.
US consumption for energy is much higher.
Yeah.
So why they project that there is a problem? Issue is that US, even if you see the inside the room, they are using air conditioning always. Outside climate is quite good. But in India that will never happen. Outside climate is good. No one will be using the AC. Air conditioner. My son is living in US. He is inside the room and running continuously, AC is running. But outside climate is quite good. But that will not happen in India where energy cost is very high. So they don't want to show that our energy cost, because more the energy consumption, greater will be the problem with the
Well,
yes, that is the because that is their weak point. They don't want to show their weak point. There's a major consumption for energy. Major consumption for energy.
well, yeah.
But India is also, there is a problem. India, there is a lot of problem, particularly environmental part. India is lacking far behind. China improved a lot. With the time, China improved a lot. Initially, China was at the top, but then now China improved a lot, and India is behind. Because if you see environmental part, water pollution, air pollution.
So that is actually a big part of the evaluation and selection of the electric filtration system. You have to follow the government regulation first. In US, we don't have a lot of restriction, but India is different. So, so last time when I was here, I actually talked about the PTFE, ePTFE membrane. But one professor asked me, "Hey, ePTF is one of the P5, which means so-called, they call it everlasting material. There is no way you can degrade. It's not degrading, staying forever. Also, it has some the bad material coming out. It can harm the human body, something like that. But actually, I never heard of something like that in US. But not when I was speaking some PTFA, one professor asked me, "This is bad material in the future." I didn't understand that. But still, if you don't have PTFA or ePTFA, then you got a big trouble in medical field, some other field. So certainly I'm gonna go over some that topic in the sustainable material development. Since I'm living in US and coming to the Jalandhar, so some portion I really don't understand, but that's reality. I have to go by the reality. So. Liquid filtration separation food processing is slightly different from the chemical plant applications, but not really a lot different. Certainly, he already covered all of those. So the membrane filtration, I have the one course, one lecture. Is that tomorrow or something? It's pharmaceutical. So it's almost the same, but slightly different for the application wise. Now we're gonna go main topics. The interesting area is DAF, MBR, and ASP. The dissolved air flotation, that topic I already covered yesterday. But membrane bioreactor, I have several slides talk about this one so that you can get some outline of what's going on. And the other one is the activate sludge processing. ASP is new area as well. So those three areas is current technology to treat the wastewater treatment. So I'm going to give you some outline for that. Well, you already covered that one. Flocculation, that's the what I cover next. This one already he covered. DAF. Well, we already covered that one yesterday. Frost related. A mineral. The same thing, but the dissolved air flotation systems. So waste water coming out, coming in, and then somehow we have to introduce some air into it, make bubble, and then you eliminate suspended waste. DAF is the description of DAF itself. They remove total suspended solid, TSS. The TSS is quite important terminology. Total suspended solid, biochemical oxygen demand, BOD is another one, oil and gases, waste. The contaminants are removed using dissolved air in water solution produced by the injecting air. You saw the picture, previous picture. Injecting air under pressure into a recycled stream of classified DAF. The feed water to the DAF float tank open, not always. Those with coagulant such as ferric chloride, aluminum sulfate. This is quite the common material for coagulant. We're going to go over a little bit in the afternoon session. He already showed you the picture in the water using coagulant. The portion of the classified effluent water living in the DAF tank is pumped into the small pressure vessel called air drum, into which compressed air is also infused. The saturating, pressurizing effluent water with air. Saturated water stream is required. Is there anyone you're actually using DAF system? Anyone? Currently? Bubble form at the nucleation site. See, the terminology of nucleating is crystallization, and nucleating. Nucleating has to come first, and then crystallization occurs. So nucleation is quite important. You have to make the nucleation. What is nucleating? Here you have solution. You're going to introduce some nucleating, boom, one drop of it. Then what happens? Somehow it creates some solid material from the liquid. That's why we call it nucleating. And then crystallization occurs. Then you can form the crystals. That crystal contains some certain ingredient in the solution. So you can separate out them. So the nucleation is quite important terminology. So then what happened to, okay, this is the DAF actual system, the schematic actual system. The bottom one, they are using membrane in the final stage, and then upper one, they use the sand filter. That's a little bit different. The activate sludge process, external seismic membrane bioreactor bottom. So the bottom one, they use bioreactor. So we're going to go over that one in detail. This is simple, the schematics, how the bioreactor works. So the waste treatment, you have to have some, you have to kill some germs inside water. Then how we can do it? So somehow you have to introduce gas molecules. Also, once you use gas molecule, then you have gas has to go out. Then somehow there is reaction to make NO2 from N. So anything, the water, something you can exhaust out of it. You know, well, you have to kill the germ first, and then somehow the rest of the material you use, we have to recirculate. So that is the right here, dissolved material. The easy way to say you have to have some sort of grab or kill or deactivate the microorganisms, and then use membrane, and then you can get the clean water out of the wastewater. Here, this is kind of a little bit long slide. It actually created 1969 in US. It started a long time ago. So bioreactor itself, yes. Because we, at that time, when right now is the same thing, the cost, energy cost is higher. The other issue is the membrane fouling associated with. So there are a bunch of research in Japan, 1970s, 1980s. Also, commercial development started 2000s. So it's kind of the recent technology. However, currently, most of the wastewater treatment plant, they do use Ambedkar. Huh?
Why is that? Most of the water treatment plant, why is that?
You have to ask when I finish this slide. Yeah, I have several of them. There is some YouTube. You have to write down there. YouTube. I don't use any YouTube at all. In US, the YouTube is not allowed. you can use personally, but officially it's
Not
not.
officially.
Officially it's not allowed. Yeah, not allowed. Yeah, and that's my habit. So once it's I'm following some U.S. rule. So probably here you can use YouTube, but I want you to write down this one. You have that one anyway. So look at it. It's kind of a little bit long, the YouTube, the video. Yeah, maybe about 15 minutes, something.
About the history? No, no. The link share.
The link is the source is right down there. Yeah.
What about the revival?
Right here. So the copy, make a copy, and then put it in the website, then you'll see. Yeah. The membrane bioreactor have emerged in wastewater treatment technology for choice of active sludge process, ASP. They replaced the ASP with the NBR. One of the most important innovation in wastewater treatment. That is true. So the microfiltration and ultrafiltration membrane technology, the pore size ranging from 0.05 to 0.04 micrometer. So currently widely used in municipal industrial wastewater treatment. I believe the India, they do use some here. I believe, I strongly believe. Because in India, you need this. The less area requirement, excellent fluence quality compared with ASP. This is always problem. Membrane, this is always problem, fouling. But certainly it's high cost this issue. Here, he already covered this one, but this is a little bit different one. So, microfiltration, ultrafiltration, small colloid viruses, bacteria, of course, you can remove it. And nanofiltration, dissolved organic matter, divalent ions, and ion specific, reversal osmosis. This is the schematics. We're going to go over anodic biozone and aerobic biozone, both of them in detail. So pre-screening, you normally use the wire mesh, and biological treatment, membrane separation, and then you can get the clean effluent. So then what is the anionic biozone or aerobic biozone? It looks like this. I don't know whether there is detail of it. Detail, yeah, right here. It happened during the anionic sick biozone environment, low oxygen, but nitrate, NO3 is present. Main process is nitrification, microorganism, facultative anaerobic bacteria function. NO3 into N2. This happens after so this is actually removing ammonia. And then what about aerobic biogen? Main process carbon oxidation, nitrification, and sometimes phosphorus removal. The function of breakdown organic matter. This is quite important. All the organic matters break down, which means the killed organic matter deactivate ammonia in biological phosphorus. Some phosphorus removal you can remove it. So here the switch comes in and primary classifier, then it goes through the bioreactor. And then MBR tank, that's what we are seeing. It's going backward. Yeah, right there. You see the aerobic stage, MBR modules back there. So the ionic biogen use aeration, oxygen absent, and use the denitrification, nitrite and nitrogen gas, which will return aquatic sludge into recycled from aerobic tank to intestinal. So the final stage is membrane unit, physically separating treated water from biomass. It's details, wastewater. I believe you already seen this one, the screening. It's really common for the wastewater treatment. And then I don't know how to spell it, how to pronounce it, ANOXIC. Huh? Anoxic. Anoxic condition involve the environmental free oxygen. And anoxic is wastewater useful for nitrogen removal and bacteria breakdown. The purpose is this one, kill the bacteria and deactivate bacteria. Allow the conversion of NO3 to N2 so that you can get it out of the system itself. Next step is aerobic tank, nitrification, actually nitrification. To create aerobic condition by diffusing air. So certainly we already covered that one. So nitrification takes place. Ammonium is converted to NO3. Wastewater, there are a bunch of ammonia there, so you need to get rid of that. And membrane and filtration. So there is some cartoon back on the right hand side. And the activate sludge and the water bubbles. This is the membrane. So more common in industrial setting, and the other is more common in municipal water setting. The municipal water has a slightly different MBR system and then the industrial setting. Yeah, membrane module right there. Here, membrane module is inside. And that's the difference. Application, water, wastewater. Probably this is a big area, wastewater. There are 3 types of membrane. The hollow fiber, he already covered that one, flat sheet, and then tubular. Membrane, there are 3 types. I don't know whether you can see the difference. You have to look at the picture. This one, probably the Professor McLeod, he showed this one. So, in fact, they do use a lot of ceramic material, like this, hollow fiber, flash tube. How you want to clean? So clogging is always an issue. So physical cleaning conducted by back flushing membrane. This is a really common method using back flushing. Relax period, permeate withdrawal is stopped so that the skull can wash right off. And then chemical cleaning. I believe he already covered that one too. He covered. And this is some removal efficiency. So suspended solid, effluents and BOD, and phosphorus, total nitrogen. What is the advantage? Less area required, less retention time, can meet the strict discharge limit, lower sludge protection, reduce elimination disinfection. Disadvantage certainly is high capital cost. So most important thing is operating. See, operator is quite, he has to know, she has to know how it works. So, operator is quite important part of it. Complexity of process mainly due to membrane maintenance and cleanness. This is a bit different area. Activated sludge process. ASP process. So, once you got your material, use the source. Then there is video coming out. So it will help you to understand a lot better. So everywhere I put the source there, so you have to look at it that way. So I did not know that in India we can use the YouTube video. If I knew before, I can put it in. But in US we cannot use it. this process is used for treating a sewage where microorganisms degrade an organic material, decompose organic material to separate in future classifier. So the important issue is how we can deactivate the virus and bacteria. And that's quite important issue. This is the activate sludge process. So sewage and screening and grit removal, you already knew, a primary classifier. And then some portion, which is the drainage, it comes down here and filtrate, aeration tank and sludge, and then sludge dewatering fin down here. The upper effluent and aeration tank and secondary classifier, disinfection, and you can get the treated water. Typical characteristic of domestic sewage. This is not India, this is for US data. Important, this one is the kind of summary of the previous slides. Wastewater treatment to access quality treatability, wastewater BOD. BOD is biochemical oxygen demand. And then COD, chemical oxygen demand. And TSS, we already covered that, total suspended solid. TDS, total dissolved solid. Here, another one, TKN. I'm not sure what that is. Textile, I have to look it up, but I forgot to look it up that one. Total amount of organic, inorganic nitrogen compound in the wastewater. Biochemical oxygen demand, 5 days. And then chemical oxygen demand, total suspended solid. You can look at it. Oh, I think that's the final slide that I have. But the important thing is the MBR, membrane bioreactor. That's quite important, the message that I like to give you. What time?
Sir, timing is 12.
Huh?
Timing is 12.
I'm not really sure.
So, sir, you take just a 5-minute break so that.
Yeah.
So, everyone, this lecture is over right now. So, the next. Sir, can I volume up so that it will be more audible?
Okay. The flocculation is part of the pre-treatment. So the when you look at the program, pre-treatment is day 4, at the day 4. I actually brought some samples. What is most popular pre-treatment filtration aid that you know of? Huh? What did you say?
Candle filter.
A candle filter. The pre-treatment, well, we're gonna go over day 4 anyway. So I'm not gonna go. Here, you already seen that the water. So if you use the flocculant agent, then it clear out the water quickly. So the raw water here, once you use the coagulation agent or flocculate, then it happens, agglomerate particles. And you can actually remove it by sedimentation. This is essence of pre-treatment process, solid liquid filtration and separation, particularly in water and wastewater treatment, mining, food processing, and chemical manufacturing. So efficiency, sedimentation, flotation, filtration, aggregating the fine suspended and colloid particle into larger, so making agglomerate and each separate by sedimentation process. This is kind of schematics. Particle surface charge. You have to use the coagulant, the agent, add it. Then it's more likely a coalescing phenomena. It's same concept. The coagulant making big particles so that you can easily eliminate the microflux. So every time when I have the slide, that is the source right there. So if you like to understand in deep detail, then use source, okay? I wrote everywhere. Some of them are research paper, then it's tough because I select the important part from the research, the journal. But like this one is not research journal, so you can go through it in order to understand better. The colloidal micelles are closely related to coagulant flocculation and processing in wastewater. Neutralization, coagulation, flocculation. So some particle is negatively charged, and if you use some agent, and then it creates the bundles, coagulant, coagulation, flocculation. In fact, the coagulation, flocculation, I'm not really sure why they separate. It's most likely a similar kind of phenomena. I'm going to ask, what's the difference between coagulant and flocculation? Anyone?
Making the molecules bigger,
Mm.
utilizing and making the molecule bigger.
Uh,
And flocculent, I think there is another particle. I'm not too sure that they help them come together and make a macromolecule.
we're making bigger molecules, that's for sure, but I don't know the difference. Actually, you can, I have to look it up. I can find out. Because I have chemist background, so somehow you have to look at the what's different. I can find out. That's my homework. So block diagram primary water treatment plan with the DAF technology. We already covered that one. Feed water, cause solar separation, and fine, and you have to use coagulant. See, any dewater or wastewater, you got to use coagulant. So sedimentation velocity is really fast.
What is the role of sodium hypochlorite there?
What?
Sodium hypochlorite is what I mentioned the first after feedwater. NaOCl. So after feedwater there is NaOCl, chlorine. Just on the left there is a feedwater, and after that there is NaOCl.
Emphasis. Oh,
Chlorine hypochlorite, sodium hypochlorite.
sodium hydrochloride. Yes, that is correct. Yes.
Yeah. What is it?
Ah.
I think that is neutralizing agent. Most methods are
Well, that's really a good question, which I don't have answer. So,
I think most of the wastewater they are in acidic in nature, and just to neutralize that, you are using this.
it's a neutralization agent. Neutralization agent. You are correct. He has answered, but I didn't pay attention to it.
After feedwater, there is NaOCl.
But anyway, the source is there. The source is there. So if you have a question, you look at the source, then you can get the answer from that. Here, the liquid filtration is not a small area; it's huge area. There is no way you can get all the information that you have. So even myself, if it is related to the diesel engine area, I can tell what is right, what is wrong. Some of the area is really tough. It is really huge area, liquid area. The air filter is a bit smaller than liquid, not a bit, it's a lot smaller than the total liquid filtration. No, you have to use a flocculant. Wastewater and water treatment, you have to use flocculant. That's the first step of doing it. Coagulation. The neutralize electrically charged particles, well, that's good. That cause them to depend on each other, remain dispersed in the suspension. The coagulant typically salt, like aluminum sulfate, ferric chloride are added. These coagulants relate positively charged ions and they stabilize the negatively charged particles. These stabilized particles begin to clump together, microflugs. The common coagulant inorganic Al2SO43 and alum and ferric chloride, ferric sulfide. Organic one, polyamide, and what is flocculant? Flocculant, after coagulation, gentle mixing is applied to encourage the collision and bonding between the particles. Flocculant often is high molecular weight polymer. That's the difference. The other one is inorganic material. It's coagulant. And flocculant is polymeric material. That's different. Wow. Yeah.
She has found that coagulation, chemical process, flocculation, physical.
Oh, physical process.
Coagulants are added, so there is a chemical reaction. When your polymers are added, only increase the size of the particle. So no chemical.
Wow, that's a good answer. Yeah, that's a good answer. That is really great. Good answer. Yeah. Yeah. If you like to learn something, then I normally suggest you to teach. And then you can learn a lot like that. The answer is right there. Physical state or chemical state, chemical reaction state. That's big difference. La, la, la. Here, the flocculation, all the material right here is polymeric material. So it's a physical nature. It's a physical nature. But previous one is the all inorganic material, which is chemical reaction. So, like I told you earlier, I love teaching, but I hate evaluation. In US, that's a big part of it. In US, I don't know whether it works in India. I doubt it. I know. And so I told you earlier, nowadays chemical engineering field, there are more women than men. Yeah. In US, long time ago, you cannot see any female student in the chemical engineering field. Nowadays, more than 60%. So looks like my habit is look at all the pretty woman, pretty lady only. I didn't actually notice it when I read the process evaluation sheet. You always look at the prettiest woman. You never look at me. So the public speech, important thing is eye contact. Eye contact through everyone. But I did have some issues. Only look at the pretty one, not everyone. But the girls, they are quite sensitive. I did not know. But I always got that kind of the comment through. Anyway. The after coagulation, flocculation, sedimentation, classification, filtration, and dewatering. The application, drinking water treatment, wastewater, and mining, mineral processing, and food beverage. The key consideration, pH also, pH is quite important. The dosage optimization critical to prevent overdosing. The mixing condition must be controlled. It's kind of the busy slide. The coagulant, aluminum sulfate, ferric chloride, polyaluminum, all of them are actually, if you look at the flocculant, it's organic material, polyacrylamide, and the flocculant, another one, and starch-based biopolymer. There is 8, bentonite clay, and chitosan is there too. So one of the flocculant, chitosan, that's the natural material, natural polymer. Currently, the chitosan is quite popular material because it's a natural polymer. So actions. I believe this is a really good table for choosing right flocculant and coagulant itself. Polyaluminum chloride, this is more expensive than aluminum. Chitosan, expensive, less stable than synthetic alternative. Chitosan is expensive? Anyone knows? Chitosan is expensive? Huh? Oh, really?
Used mainly for medical applications.
Ah. Yeah. Yeah, if it is a medical application, it certainly is expensive. Certainly the starch-based the biopolymer, that's another important one currently because it's biodegradable substance. So both of them are quite popular. However, it's less effective than synthetic flocculant. Let's see, chitosan. It's cosmetic for industry. This is another trouble. All of the natural material or biodegradable material, the effectiveness is not as good as the man-made, the polymer and other synthetic materials. Well, you already seen that, the pictures. The use of coagulant or flocculant enhance the rate. Of course, we already knew that. Well, this is quite important, the principle, zero potential. So if zero potential being, Probably everyone knows zeta potential. Do you or not? That is called the stun layer. Right there, stun layer. So the negatively charged particle, then there is the positive the charged solution. It has some sort of the boundary layer. So they call it stun layer. And then it's dilute it's a mixture of the positive and negative charged the effluence around there. So zeta potential is this one. We call it zeta potential. See, this morning I noticed one thing. The AFS, the American Filtration Separation Society, we have short course. However, that short course is not as extensive as this one. Especially Dr. Mukhopadhyay, he knows a lot about the media itself on the filtration application. He is really expert. But the American Filtration Separation Society, I don't know, maybe we can find something. But currently, we don't have class like this format. So I believe this course, I believe you are really lucky to be here. Because in America, we do not have course like this, extensively like that. Also, I noticed that in American Filtration and Separation Society, I never heard of MBR process, something like that. Because somebody need to pay attention to it and create something. The zeta potential, it has been around for a long time, importance of it. Why it is important? So the higher zeta potential, the greater the electrostatic repulsive force, less tendency for particles to get together. So you need to make something really lower the zeta potential. So in order to make the agglomerate. That's why zeta potential is important. Coagulation. Stability will corrode the particles. They're stable and unstable. So you have to make unstable. So at the large zeta potential value, which is minus 40 millivolt, will make the system very stable. Then coagulation is not occur very well. So coagulation means destabilize colloid system by charging the electrolyte concentrate, reduce the zeta potential. Well, try to reduce zeta potential. The coagulant lysis is all inorganic material, especially Fe, Al, Fe, and Ca. I don't know whether we have the, maybe later. The compound used are ferric sulfate and ferrous sulfate, aluminum chloride, aluminum sulfate, aluminum. Selection of proper coagulant is based on experience and test. The coagulant is the kinetically the second order process. Coagulant rate depends on the square of solid concentration. It's slow and dilute suspension like potable water treatment. Sequence of coagulants needed. Ionic concentration suspended ingredients. Somehow you have to reduce the zero potential in order to make the agglomerate. That's the conclusion. How you can destabilize some natural polyelectrolyte effective flocculant. So flocculant, natural flocculant, starch, gelatin, pure gums, and polyacrylamide. We are actually talk about a lot something previously. Polymers are characterized by average molecular weight. The high molecular weight, 20 times 10. This is really high. This is polymer. Medium size still is high. Low molecular weight still it looks to me 10 to the 6th power. That's really polymetric material. It's a long chain actually, molecules. So disperse of flocculant into water solution and transfer flocculant in solid liquid surface. I don't know whether I have to read everything. Whenever I say you can read a lot faster than I do. Why don't you read through it? Huh? Yeah. I don't want to spend a lot of time to read it. So probably if you need this information, then you can go through it. So this is the experimental setup, coagulation. So same agitation level, but you can see which one is the coagulate fast. So I don't have this setup. This setup from Dow Chemical. Dow Chemical. They have exactly like that. The procedures, how you can operate that setup. Also, TSC test is really commonly used for the flocculation and coagulation. The setup is right there, but you have to use the here, right? The timer, how you set it up, and slurry, and filter paper down here. This is the actual measuring devices. CST test is quite popular in the laboratory when we do the flocculation and coagulation research. The procedure of CST. What is the CST right there? Capillary suction time. Capillary suction time test. So 20 seconds is considered fast filtration. 120 is CST test result. This is interesting one. So the coagulant, this one. When you look at the chemical chart, coagulant is around this area. This is same thing, same as the one you saw it, but it's a little bit different setup. The one that I showed you, that was the in the Dow Chemical company. This was, you can actually set it up like this. So decantation ability ratio and time, when you look at the different coagulant, then you will see the decantation ability ratio much better with the aluminum flux than FeCl3 flux. The sludge treatment. I got this data from the Korean research, is Hanyang University data. You can actually look at the size of the agglomerate. So it's a TiO2 process. They use a TiO2 as flocculant. So they keep saying that the TiO2, use the TiO2 as the flocculant. Oh, okay. I think that's the end of my slide. The pre-treatment. I brought some samples. So day 4, you can look at the samples itself. I did not bring a lot, only 2 or 3 cc's of samples, so you can actually look at the filter A. I still have the jet lag issue a little bit. I don't know whether it's my age related or not. I hope not. But anyway, I like to conclude the flocculation class because this is the last slide. So if you don't have any other questions or something like that, we can start lunch a little bit earlier. I don't know what time is it.
Yeah, it's almost just almost 5 more. Okay.
We have 10 more minutes then. See, I have the Fitbit watch. I brought it here. I tried to synchronize to my cell phone. It didn't work here. I don't know what happened to it. If someone can help me to synchronize, it'll be wonderful. But still, without it, still I can manage. That's why I don't have watch.
She will help you to get connect work with the phone.
Really? Really?
We can try, sir. We can try.
Okay, then I'm going to bring it tomorrow. the fit is really good because I'm runner. Yeah, so when I run, it has every information down here. Also, you can use this one. However, it's a little bit heavy. Also, my sexy pants. I don't, I don't, I, I'm not used to carry. Also, the pocket is not big enough.
I would suggest you to use a boot bag. That's better than fit.
Okay, I have to turn it off. I don't know. To me, I don't normally eat the fried one. Only eat inside of it, not outside. Okay. Yeah. You're gonna see this one at your book. Huh? It started with something like this. The filtration, when the filtration started, huh? When you look at the some pictures in the tomb, murals, this one is around 1900 BC eh, in Tibet. But right hand side, this is the quite famous drawing. They are actually making sake. The making sake, there are several processes of filtration associated with it. Even though a lot of people they are doing it, they actually squeeze the fermented rice, making sake. So, in fact, the filtration started BC probably more than 3,000 years ago. So, filtration has been around for a long time. One thing I can tell you one thing. In the Bible, God created earth. He created several substances, day and night, and human as well, and then something. There are some separation and filtration are already there when you create something. The water and earth is a separation. So separation actually started from way back when the creation of earth and human beings. Separation and filtration has been around really long time. That's what it is. This is what I told you earlier. The Fuji Mountain. Fuji Mountain, around that area, there are a lot of tasty water. Huh? You can get it from. How? How come? This is what it is. Fuji Mountain. And inside looks like a river, kind of. And then there are some sand coming out. Some of them are going into the sea. Some of them are you can actually drink. So sometimes it takes more than 100 years from starting point to the where the drinking water foundation coming out of drinking water fountain. So that's where sand filtration started. This is what the Professor Iritani started on his book. That's why I like it. But he didn't improve his book. Also, he didn't use Darcy's law. He used his own resistance kind of study with. So you will see the book, but the book is really good. It's easy to understand. The other thing is there are a bunch of joys, pictures there. That's what I like. So when you have time, it's not that difficult. The equation itself is not that difficult to understand. There are some integration in it, but that's all. So I recommend to read that book. It's only less than 100 pages. So that will help you to understand liquid filtration basics. Do you have a copy of it? Electronic copy of it? Not yet? Not yet. So actually, that book started something like this. In fact, I really wanted to use that book for tutorial 2. But since you don't have it, that's why I made a couple of slides. Okay, here. Professor Mukherjee, he covered something. But I'm the person who actually did some experiment. So it's comparison between air filtration and liquid filtration. There are so many similarities. That's what I like to say something about. Here, the less than 1,000 nanometer, 1 micron, then interception, and what about the 0.3 down, then diffusion, electrostatic effect. This is basically for air, so airstream, something like this. Then, well, the source is right here. This is the air filter, particle capture in the air filter. What about the particle deposition mechanism in liquid? The difference, look at the difference. But surprisingly, we can apply some of the mechanism to the liquid filtration. Hydrodynamic interception for particle having radius greater than distance below the flow stream, which carries particle and surface collecting grain in the bed. Suspended particle will be intercepted by surface and collected. This concept is really same as the air filtration. Also, diffusion deposition in liquid suspension, small particle less than 1 micrometer surface. In this case, diffusion can cause random of particle, which is control rate of particle deposition in the liquid bed. So this stays the same. Electrostatic interaction. This effect is a lot less in the liquid, that's for sure. And straining and sedimentation should be considered a deposition mechanism for larger particles with high density. The other is the electrical double layer repulsion. Van der Waals force are important for collecting small particles. Actually, this one is stay in the air filtration as a liquid filtration too. Oh, what?
No, sir, I am not asking you. You are just relaxing my mouth.
This is quite interesting.
Yes, sir.
Okay. Is that okay? That, yeah. Okay. Surprisingly, in the liquid, the dendrite formation is occurring. So this is normally, air is normal, the phenomena, dendrite formation is. But however, in liquid, somebody did research on it. It's the same thing. It's dendrite formation. As long as the liquid flow rate is slow, not so in depth filtration, particle deposition normally in dendrite form. This is exactly same as air filtration. It occurs in liquid as well. So most of the particle will be collected by web formed by various capsule particles. Initially, the filter efficiency increases with time due to this dendrite formation. So there are some breakthrough, which means it's not going to stay long. It drop out, not like air filtration. So this one we already covered that one. But important thing is, whatever the air filtration mechanism, it can be applied in the liquid as well. That's key message. We already covered that one. Cake filtration, depth filtration, surface filtration, and cross-flow filtration as well. So you can read through it, this one. And cake filtration, depth filtration. We actually covered this one a lot. So cross-flow. Yeah, cross-flow is quite important part of it. And the Professor Mukherjee I don't know. I actually pronounce his name Mukhopadhyay. Why the last spelling HYH is there? I'm not wondering. Thai.
Yeah, DHYAY. It's not the, or you can say Mukherjee.
Okay, nowadays, if I have the grandkids, sometimes they ask me to make some the names of it. So I actually create one for my granddaughter. Her name is Ayla, but Isla. So Ayla. See here, pronunciation a lot easier. Ayla. Mukhopadhyay. I don't know. Don't talk to him. Yeah, surface filtration, cross-flow filtration. In fact, the upper part of the drawing, I got it from the book, the Iritanes book. So, I think the drawing he presented is really close to this one, the depth filtration and particle capture, collecting media. Then why you have to use filter aid? Try to avoid the particle collection on the filter media. So that's why you need to use the filter aid. Well, this one we already discussed previously: surface filtration and depth filtration, cross filtration. I got all the drawings from your book. Yeah, no. The book you're gonna have it, yes. So if it is cross flow filtration, somehow you have to back pulsing is quite important to remove the particles on the membrane material. The straining, actually straining is a key mechanism for the liquid filtration. And straining, again, larger particle, then the filter medium opening up and removed. In K filtration, same thing. Right here, you block the holes. So in order to prevent the high pressure drop, that's why we need to use the filter aid. Diatomaceous earth is really popular filter aid. However, recently they found out that material is carcinogenic. So the handling is a big issue. That works really good. But recently found out that is carcinogenic material. That's quite important one. But when the Iritani wrote, actually he did not write the book. His student write the book. He's not write the book. It's a manuscript, something like this. But in fact, I'm the first person making English version of it. But I'm gonna add, and then add a lot of other material into MBR as well. I don't know how long it takes. I hope in 3 months or so. The issue is currently he is preparing for our testing equipment, filter testing equipment. So depth filtration, adhesion, electrostatic force, and inertia, interception, straining. Here look at interception, inertia, and diffusion. That's so-called most likely in the air filtration mechanism. Cross flow, we already know. Cake filtration. Compressibility is quite important one. I don't know whether I have Cousin and Carlson equation here. That's right there. Right here. That's the end of it. Right there. No, that's fine. Yeah. This one S is the Kozeny constant there, but it's more likely the Darcy's equation. But actually, the Kozeny Kalman, they actually consider big particle as well as small particle relationship between. Yeah, the surface depth K, discretion is there, and media used, and common application. Can you bring the sound a little bit lower?
No, sound
Lower.
Is it okay, sir?
Yeah. Oh, yeah. I think it is better. I hope. So, pressure filtration, oil purification, further processing, and cake filtration, centrifugal. And this one, pre-cut filtration. That's what I like to look at it. This one. Yeah. Pre-coating is process of applying a thin layer of filter material, such as this one is issue actually, diatomaceous earth. This is really popular. A lot of the people, they are still using it. But the important thing is, this is carcinogenic material they found out recently. So when you're handling, then you need to be careful. Yeah, I brought some of the samples, cellulose, rice, you'll see later on. So how is it working? Pre-coding. This is what it is. Filter A is right there. Filter A. That's why it actually avoids blocking of particle. That's what it is. The centrifugal using perforated basket with the filter cloth outside. The same principle. And perforated basket, filter cloth, mechanism, and feed system, discharge system. I'm going to use this one for the so, key component of centrifugal filtration, perforated basket and cylindrical metal and cloth inside and driven mechanism rotation certainly. Feed into the slurry into the basket. Discharge system. The advantage, fast separation, for large volume continuous. Can handle abrasive or crystalline solid and relative dry cake formation. And the limitation is not suitable for very fine and incompressible solid. Cross need a regular cleaning, certainly. So the trouble is the cost of equipment very high. Where is the application? Where are the sugar industry, pharmaceutical, and chemical process? I already showed you this one. But this is my last slide. This is gonna be. I actually shipped this one to the Dr. Mukhopadhyay, but he had hard time go through custom and the immigration because I separated into two pieces because it's. I'll show you. I'll show you. Actually, this one I use a lot when I do some the filtration research. It's small, but it's really good for liquid filtration testing. See. This is the, you can put any type of media right here and close it like that. Also, there are packing material here. There's no bypass at all. I bought it 30 years ago. At that time, it was $1,000. Right now, I don't think you can buy it. If it is available, probably it will be about 3,000 or more. Also, this is made out of the stainless steel, but lab purpose, you like to see inside the solution. So the flex glass is not bad, but you cannot apply a lot of pressure. That is another issue. But this is small one, but it's really handy. That's why I sent some drawings here. Oh, where is it? Hey. Okay, would you please open up the one?
This one or
No. Go back to the
which one?
media design. Media design. Media design.
Designing filter media.
Yeah, that's it. And open up. And then go down further.
This one, sir?
Yes, look at that. Yeah. Exactly the same picture, this one. But important thing is the theory behind it. No. Up. Right here. Oh. This one. Okay, here. this is the basic equation you're going to use today. So, engineering mechanics, important thing is stress-strain relationship. Then we heard about a lot. Then how actually you can get stress and strain. That's what you're going to do today, using this equipment. The theory behind is right there. Okay, here. This is stress. Delta P, that is, you're going to measure the pressure. R, diameter of this capillary. Okay? Only this capillary. Diameter of this is 5 millimeter. 5 millimeter. I want you to write down. It's not diameter. You have to use radius, 2.5, but it's 5 millimeter. What about length? Length is 79 millimeter. Length. Oh, I have to check whether 79 or 78. It doesn't really matter. Yeah, 79. I don't know whether you can see it or not. This is drawing along with this one. Here, this piece is filtration section only. This is making slurry, and then you're gonna inject that slurry right here. How? And then, the other side, like this. Exactly the same amount of solution inside. And put it there, like this. And then you have to insert filter media right here. And close it. And then you have to use air pressure. And in fact, you have to measure the exact pressure. Then somehow you have to measure the timing. Goes through all the liquid out. Basically, here, Q, you're going to measure it. And then P, of course, you know. So once you know the pressure, and R, we already know. We already know the length. Then you can get stress right there. You can get stress. And then what about strain? How are you going to get it? Here is the volumetric flow rate. So you actually get the weight. You don't need this, right? Okay. So once you obtain the Q, then everything is already you have. So you have strain rate. It's not strain, it's strain rate. So then what is viscosity? How are you going to measure the viscosity? Use Newtonian flow equation right there. You have strain rate, you have stress, then you can obtain viscosity. So today we're going to use water. So you have to find out whether your answer is 1 or not. It's a quite interesting one. So Originally, this one actually I like to make, well, I want them to make something like this so that we can use different slurry and then test the constant pressure experiment, constant rate and variable rate, something like that. That was the original plan, but it didn't work. But it's a lot better because use this equation in order to understand strain rate and stress in order to get viscosity down. So I believe it's going to be fun. A fun experiment.
Sir, Q is the flow rate, is it?
Huh?
The Q?
Okay, yes, mass flow rate, yes. Flow rate, yes. So you have the balance and then stopwatch. So you can get it. Okay. So looks like it's a quite simple task, but basically it's quite important as far as engineering principle, understanding engineering principle. So I hope you can enjoy. See, I use that equipment a lot when I working with the Cummins diesel engine company. This is small one, but you don't have to use a lot of liquid there. That is better.
Accuracy level,
Huh?
accuracy wise errors or something. Accuracy level will
Every experimental procedure, you have a lot of error. Yeah? So how you're gonna get it? Repetition, 10 repetition, something like that. It's an average. So the Ajay and myself, we spend a lot of time to prepare something like this. See, whenever I have some invited lecture, something like this, I always emphasize experiment, experiment.
That is, actual learning.
Yeah, the hands-on experiment is quite important to understand the principle. So this is actually design of that one, and then I really want them to make something like this. I wrote the instruction up there.
Okay, so who has developed this?
Huh?
You have developed it?
Yeah, I want them to develop it here. So I thought, I don't know whether they can prepare it in time. That's why I brought my own stuff. Actually, Jose, he spent a lot of time. the starting equation, the phi delta P R 4 times, and then AQL, that's the famous the formula. Hmm? It's okay. Now we can do it. Are you going to demonstrate, or some of them come here and do the experiment?
How much pressure we should use?
Just minimum, but you have to read through it. I don't know whether you can read. Yeah, 2 is good enough. 2 is good.
We have to use sand also.
Huh?
Have to mix the sand also. Sand.
Huh? Sand, I don't know whether it's necessary.
So then it will not block the water, only water.
Whatever you like to do, go ahead. Sand, probably. Did you bring?
Yeah, I have.
Yeah, why don't you do it?
We have two types of sand. This will make slurry, and this is a larger, bigger one.
I think that's okay. This
For
one,
cake formation.
yes. Do you have copy of the paper?
Sir, yes, sir, we have.
Okay.
Yes.
If you look at the pore and permeability, the equation 11 is over there. We are using equation 11, so-called Hagen-Poiseuille's equation. Hagen-Poiseuille's equation.
Yes, sir.
Huh?
Which one? Yeah, this one, no?
Correct.
Yeah, this one, this one.
But Hagen-Poiseuille's equation is 11.
11. Okay,
Yeah.
okay, yes, sir.
Uh, the fluid mechanics.
V is what?
Huh?
V? The, V
Okay,
is
V, instead of we are using Q
Q.
instead.
Okay.
So I hope you could go back to your place and then try to make something like this.
Sir?
No, you have to hold.
No. But we are taking the
Okay.
this filter is not blocking anymore.
Yeah. But from now on, you are the instructor. You have to tell them, okay, what to do. Okay. Understand? Or do you want me to say something? Well, yeah, he need assistance. Anyone come out and help him out. So if you really like to do experiment, then somehow you have to know viscosity of liquid you are going to use. That's quite important. Also, once you obtain the viscosity is function of shear rate, which means the rate is faster. Normally, what happens? Viscosity drops. So liquid filtration, temperature is important, but viscosity is more important parameter. So this experiment will help you to understand viscosity value. Yeah, you don't have to sit down there. Come out so that you can have some your own hands-on experiment. Probably I need to make group. Once they finish it, then the other group come up with the experiment. So 5 of them, one over there. Yes, and then 1, 2, 3, 4, 5, and the other 5. Wow! Right here, maybe 6 over there. Okay. One of them don't have my name on it. This one, I don't see my name.
Yes, sir. Your name is not good. In tutorial also I need your signature.
I think today I did.
Tutorial 2 date selection.
Ah,
So every time I am taking a signature.
oh, I
कैप्चर कर रहा है वाला तो बोल ही नहीं रहा कुछ, वो साउंड ही ले रहा है।
Somebody check the timing. Timing start and end. Yeah, how many seconds?
About 1 second.
Uh, well, somebody need to check. Ah. Jay, somebody check the timing. Still, you have to check the timing. Let's say it is 1 second. Huh? Yeah, 1 second is fine. 1 second is fine. Yeah. If it is already set up, then you don't know what the problem is.
Try in bigger one.
Now we're going to use the bigger setup. Do you know that the mass Mass.
And
The mass. How much?
it's 1200 ml.
Are you sure?
Yeah, you can check it.
Okay.
टाइमर कोई चालू कर रहा है? आप चलो।
What about weight?
What is happening?
We are doing experiment. Big one and small one. Wow, that's good. The pressure is quite low.
Small one is completed.
Yeah.
Huh?
So quick. It's so quick.
Okay.
Less than a second.
Now what we are measuring? Volume of
Volume flow rate. That's what we are. A lot better than a small one. But pressure. Here. Look, the pressure is so low. Ah. Golly.
ये थ्रेडिंग कवर नहीं हुआ है इसको वो प्रॉब्लम एक्चुअली है इससे नहीं बनेगा इससे आप करके रोटेट करेंगे इसको घुमा के बंद नहीं करना है इससे हाँ से
About 18, 1 8. Yeah.
there zinc blending in US? Because in India there is
I understand the Indiana is a big plant. Yeah. All community is for coming. Yeah, the city is big. Also, the plant side is huge. Yeah. So they call it campus.
My question is there petrol blending with ethanol in US?
Ethanol, of course. I didn't check it.
Because the Indian government is right now they are doing 20% ethanol and blending, and that's commercially available, and they are now planning for
Is that for coolant application?
yeah, coolant application.
Coolant application, isopropyl.
Also became Indian government is now test commercially available. They are planning with 10% of
I
with
see.
also became.
Uh-huh.
My question is there any blending in US for diesel and petrol obviously? Diesel?
Diesel engine, I'm not sure whether they use the 4010 or not, but I didn't pay attention to it, so I don't know. I don't know.
My company has once exported a fuel filter.
What is product?
Diesel filter. Diesel filter.
Diesel filter,
Used in
what?
trucks.
Fuel or hydraulic oil or
Hydraulic oil.
hydraulic oil. Hydraulic filter?
Not specific hydraulic filter. Mostly diesel oil refineries.
Oil refinery, I see.
That kind of
Mm.
like in total them. With housing and with the architecture and practices and we have a split.
Mm. So how long have you been working with them?
Around 2 years.
Oh, so you are a new engineer then?
No, sir, I am not an engineer. My background is of commerce.
What?
My background is of commerce. I am a commerce student.
Oh.
I did my MBA from my head college.
Ah.
The business head.
Yeah, this is important. Yes. Ah.
फिल्टर ही लगा थल्ला
एक बार और करें। असल में ना ना वो प्रेशर चलता है, कुछ टाइम लगेगा रहना हमारा और तो जग गया नहीं कुछ टाइम मारना बात है मुझसे
देखो तो उसकी देखो फिल्टर हाँ अच्छा लाइव स्ट्रीमिंग लाइव भी दिखा दो अच्छा जो इंडस्ट्रियल विजिट है रिकॉर्ड करना होगा तो कर लेंगे नहीं नो अलाउड नहीं फोटोग्राफी आप ग्रुप फोटोग्राफ से करना ना कि एंट्री करते हुए तो दिखाई सकते हाँ वो किसी भी किसी को ग्राउंड में डालना आप इतना करना कि बाहर आप क्या करते ना आप मेरे साथ गाड़ी में जाना और सारे लोगों को जाते हुए आज जब हम निकलेंगे ही करके बस में बैठते हुए बस को बस लेके जाएंगे तो बस से उतर के जाते हुए और कोई भी लाइव और फिर जैसे हम लोग आएंगे बस चाहिए ले जाए देखो वहाँ करेंगे क्या मैं तो जाऊँगा अब वहाँ मेरा थोड़ा सा हमें दिखा दे आप नाम से बस कर रहे हो आप लोग बता फिर कहीं बैठ के कोई हॉल में थक जाएगा तो मैं दिखा रहा हूँ मैं भेजा हुआ सवेरा में आया पंजाब में पंजाब के लिए लोग रात में ही आएंगे आपके ग्रुप
You have idea what to do?
आज का लाइव स्ट्रीमिंग क्या है उनको भेजोगे ना तो मैं दिखाऊँ मिनिस्ट्री को भेजूँगा आज वाला मेरे को भेजो यहाँ भेजो ना कोई नहीं हाँ डेट वाला आया हुआ है डेट टू का आप लोग बताने इनको क्रेडिट में नहीं, जैसे वेर का है, इनको क्या जरूरत है क्रेडिट को?
जरूरत तो हमें भी नहीं है सर वैसे।
कर लो, छोड़ दो, उनका सर्टिफिकेट तो दे ही रहे हैं। स्टूडेंट्स देख लो जैसा अच्छा है।
अकेडमिक में बेनिफिट है, बाकी सब चेंज
एकेडमिक में है उसको
वैसे सर अब अगले कैश के लिए चाहिए नहीं, मैं तो वैसे लगा
सर्टिफिकेट तो मिल जाएगा। सर्टिफिकेट कैश के लिए क्रेडिट का जरूरत है आपका।
टाइम दीजिए वो मेरे को मिले सारा कुछ डाल दिया सर। लेकिन मैं
BIS तो यहाँ हजारों लोग कर रहे
Actually, we have tried to find out the viscosity, but it doesn't matter.
Because it's water.
So,
Delta P you know, R you know,
uh-huh.
L is the thickness, Q.
No, L is length. Length. Oh, where is the other?
Length of
The other piece. Yeah, the length of capital.
What is the equation? Basic equation. That is based on Poisson's.
Huh?
Poisson's equation.
This equation is Hagen-Poiseuille equation. Hagen-Poiseuille equation.
Go back to that.
So you gave up?
Calculated the flow rate.
Huh?
Flow rate.
Flow rate is quite low, about 10 seconds or so.
No. From this method.
Ah.
We have calculated. हजार ml at pressure of 1 bar.